Today we're going to be going over Le Chatelier's principle, and what that means is a system at equilibrium shifts to reduce a change. So basically the system tries to undo whatever you just did to it. We're going to go over 3 different stressors. The first one is adding and removing components. Second, changing the overall pressure of the system. And third, changing the temperature of the system. So we're going to be going over 2 problems that will address all 3 of these things. So problem 1, we can go through together. We're going to start with ammonia gas, and then nitrogen gas and hydrogen gas, and the arrows just mean it's reversible. So the first stressor we're going to do is remove nitrogen. This is going to cause the equilibrium to shift towards the products. So we can see we're decreasing the nitrogen and we want the system to get more of it by going towards the products. Stressor 2, if we increase the volume, the pressure will decrease. We can use the ideal gas law to see this. So volume increases, pressure decreases. This is going to cause the equilibrium to shift towards the side with more moles of gas. And that side is the products. And now we're going to change the temperature. So first we need to see if it's endothermic or exothermic. We can tell that it's endothermic because the heat needs to be added to the reactants to break the bonds. So for endothermic, the heat is going to be used as a reactant. And for exothermic, we're going to treat the heat as a product. So if we increase the temperature, the equilibrium will shift toward the products. So yeah, the reactants are increased, so we want to go towards the product to make more product. Problem 2. We're going to use calcium oxide plus carbon dioxide becomes calcium carbonate. So the first stressor, we're going to add calcium oxide, and this is going to actually cause no shift. It doesn't shift because adding solids doesn't affect equilibrium. Only gases and aqueous substances do. The next stressor, we're going to increase the overall pressure of the system. If you'd like to try this on your own, you can pause and unpause when you're ready. So this is going to have the equilibrium shift towards the side with less moles of gas. So the general rule is that if you increase pressure, the equilibrium will shift to the side with less moles of gas. And then if you decrease pressure, the equilibrium will shift to the side with more moles of gas. So we see that there are no moles of gas on the product side, so we'll shift towards the products. And the last stressor we will do for this problem is changing the temperature. So we're increasing it. Pause now if you want to try on your own to see if it's endo or exothermic. The system is exothermic, so heat is going to act as a product. So if we're increasing the heat, which is on the product side acting as a product, we will have the equilibrium shift toward the reactants. That's all. Thank you for watching and good luck.